Sahil Kumar and Gyanendra Kumar are going to present our work on simulation of a small scale microgrid with a PV system and battery storage. The major keywords that we have used in our project are renewable energy sources, which is RES, and solar photovoltaic, SPV. Uh, so we are working on microgrids. So what actually a microgrid is? Microgrid is a self-contained electrical network that allows you to generate your own electricity on site and use it when you need it the most. A microgrid is thus a type of distributed energy resource, and there are two major ways in which a microgrid can be connected. If it is connected to the main grid, then it is called grid connected mode, and if it is not connected to the grid, then it's islanded mode. So in our project, we have connected our microgrid to the main grid, and we are storing the energy produced from the grid using battery and solar power. What are the main objectives of the project? In this project, we are going to simulate our microgrid for 24 hours. That is one typical day. The methods that we have used in our project are MATLAB Simulink. We have used MATLAB Simulink with Simscape to simulate our whole model for 24 hours. So here is the design or the architecture that we have used to simulate our model. As you can see on the left, we are using a 66 kilovolts generator, which is being stepped down using a three-phase transformer, and then it is further stepped down through the pole mounted transformer supplying the energy to the three loads. The loads are typical household loads with a maximum load of 2.5 kilowatts. Now my friend Sahil is going to explain the simulations for the project.
Okay. Thank you, Abhinav. Now it's my part. My name is Sahil, and I'm doing about simulation. Okay, as we can see from the graph, from 20 hour to 4th hour, the solar power generation is 0 watt. It reaches the peak amount 5 kilowatt from 14 hour to 15th hour. As a typical load changes in ordinary house, the amount of electrical power load reaches peak consumption at 9 hours with 6500 watt, and 19 hour and 22 hours up to 7500 watt. So from this simulation result, we can see that from 0 hour to 12 hour and from 18 hours to 24 hours, the battery control is performed by battery controller. The battery control performed tracking control of current, so that active power which flow into system power from the secondary side of the pole transformer is set to 0. Then the active power of secondary side of pole mounted transformer is always around 0. The storage battery supply the insufficient current when the power of microgrid is insufficient, and absorb surplus current from the microgrid when its power is surplus the electric load. And from the next two simulations, from 12 hour to 18 hour, the battery control is not performed. So, and SOC, the state of charge of the storage battery is fixed to a constant and does not changes since the charge or discharge of the storage. The battery are not performed by the battery controller. When there is a power storage in the microgrid, the system power supplies insufficient power. When there is a surplus power in the microgrid, surplus power is returned to the system power. And in the last simulation, we can see that at 8 hours, the electric load number 3 of ordinary house is set off for 10 seconds by the breaker. A spike is observed in the active power on the secondary side of the pole and transformer, and electric power of the storage battery. Thank you. Now I am handling this over to Gyanendra.
Thank you, Sahil. My name is Gyanendra Kumar, and I am going to cover the last part of the project. And there is a discussion and the conclusion of the project. The conclusion of the project is when there is a non-uniform load pattern, we should size the battery instead of entire PV system. because most load vary only for a short period and are for the rest of the time. It is preferable to size the PV system rather than the battery system in a system where entire load pattern is consistent. The load does not fluctuate over the typical time period. A battery control manages the battery's state of charge SOC by the monitoring charging and discharging state as needed. Work can also be done for large microgrids with more renewable energy sources or microgrids with both renewable and conventional energy sources. Thank you very much for the time, and the last part has some references here that we use for the project. Thank you very much.